My name's Guy Adams and I'm CTO at DataOps.live. Welcome to this Operationalized video series. In this series, we're going to look at a whole variety of new and recent Snowflake functionality from the perspective of operationalization. And the focus of today's video is Cortex fine-tuning. But before we jump into that, let's spend a little bit of time understanding what we mean by operationalization. So over the past number of years, Snowflake have introduced more and more incredible new features, and every Snowflake Summit we're treated to more and more demos, more and more incredible capabilities that bring advanced functionality to the enterprise in a simple way, functionally. The functionality gets better and better, new functionality gets added all of the time, and what we're treated to at Summit is great demos of these on stage, inside sessions, showing individual examples of how this technology could be valuable to an individual business. What I'm going to focus on here is the piece below the line, which is how do we take those individual features, how do we take those new technologies, and how do we operationalize them? And everybody who's been in the data world or really any technology world for a reasonable period of time will understand the difference between I have something working on a desktop, on a dev machine, in a development environment for one use case and demonstrate it to people versus operationalizing it where it's a full-time industrialized part of my business, where it's reliable, where it's always working, where it has a maintenance program, and so on and so on and so on. So if we consider these things at the top features, what I'm really looking at here is the feature operationalized, the feature taken to the point where it's used reliably and repeatably inside the business. So I'm going to focus less on the features themselves, although there will be some of that going through, but I'm also going to link in the description to other videos that you can watch. There's many brilliant videos from Snowflake on the features themselves, so you can learn about the features in Snowflake, the features and capabilities from Snowflake. I'm going to focus on specifically this operationalization piece. So just do a little bit of a comparison. So when we talk about a feature demo or a proof of concept, typically we're seeing it at Summit, we're seeing it from the vendor, it's being provided to us as customers, whereas operationalization is something that we've got to provide for ourselves. The purpose of a feature demo is to highlight, one or two specific capabilities of a feature and show off its power and capability, which is fantastic, and it really shows the art of the possible. But operationalization is so critical because it's only when it's operationalized does it deliver real business value. Robustness. A feature demo has to work once. It has to work on stage or in the session it's working on, and then that code maybe you've thrown away or archived and dusted off again in 6 months' time. When we operationalize something, we need it working 24/7, 365 days a year. A feature demo typically works on the happy path. You have a script, and you know that when you click here and when you type this and when you click here and you type this, it will work. And that's all you need for a demo, and that's fine. There's nothing wrong with that. I've done many demos this way. When we're operationalizing, we have to start considering edge cases and testing and what happens if things don't go that way. We can't have a system that only works when everything around it is behaving the way we predicted it would do. When we're developing demos, it's typically one or two individuals, it's a pretty ad hoc process. When we're operationalizing something, we need it worked on by more teams. One team may start developing it, another team may need to pick up and continue on, another team may need to support it. We need a much more formal process. We need to govern this work. We need change control. We need peer review and things like that. So the development process is very different. Similarly, when we're doing a feature demo, CI/CD, we're not really continuously deploying this. We're just we're running it in our own environment. We'll make a change, we'll test it. We'll make a change, we'll test it. But it's really only within our own notebook or something similar. Whereas when we're operationalizing, that automated integration and that automated deployment is absolutely critical. Similarly with the security model, the feature demo doesn't really matter if I run it as account admin. That's not what I'm showing off. I'm not showing off the RBAC model, or what I'm showing off is the functionality of that feature itself. Whereas when I'm operationalizing it, clearly security model is critical. Scalability. As long as it works for my demo, I don't really care too much beyond that. When I'm operationalizing it, it has to run not just today, but it has to run where the business might be in 2 years' time, which could be 10 times the volume. Governance and auditability. A feature demo is, it's not having any impact on an actual business. It's not, people aren't making business decisions against it. Therefore, the quality of the code, even the correctness of the code isn't actually that important. Whereas when we're operationalizing this, people are going to make real business decisions against it. So our governance, our change control, our auditability is absolutely critical. And let's focus on the end result. For a feature demo, our end result is we're doing a demo. We want people to get excited. We want people to think about the possible applications of this. And that's a really valuable piece. Don't get me wrong. This is a critical piece. And I love doing these. I love building demos. But when we're operationalizing, we've got a very different end result in mind. What we're focusing on here is reliably and repeatably delivering that business value. So that's kind of what I'm going to be focusing on today. Less of the left-hand side. I'll post some links to videos about Cortex fine-tuning where you can learn about the feature side of things, which is really cool, and I love it, and probably some of that comes out, but really I'm focusing on the right-hand side of this. So let's jump straight into it. That's it from a slide perspective. So I'm looking at a project here that I've created specifically to do a Cortex fine-tuning process. So let's consider, for example, that I had a, let me just set this back. Let's say that I was working on doing some text summarization. So I've got here a fairly long extract from Wikipedia about Hafthor Bjornsson, who you may know as the Mountain from Game of Thrones, and I'm trying to do a summarization of that. And I'm using the Mistral 7B model, and that delivers me... I've lost my... That delivers me a reasonable summarization, but it's focusing on lots of different parts of his life. I don't want to. It's a little bit long. I've got a very specific purpose for my summarization here. In some cases, I could try and improve this with prompt engineering. I could rework this prompt, but I'm going to be using this very, very extensively as part of my business. And I've got a whole set of examples that have been done previously. This has been done by hand in my sort of fictional scenario. So I've got a whole bunch of examples of what this should look like. So I want to train a model, or rather fine-tune a model, to work the same way that it's being done today. So I've got a set of examples that I wanted to follow. So it's a perfect use case for fine-tuning. In fact, the data I'm using, and again I'll include a link in the description, is this data, Unified Summarization Benchmark. And you can go and download this. It's freely available data. So this is the actual data that I'm using as part of my fine-tuning data set. So I've been developing my my pipeline for doing fine-tuning in DataOps. I've been doing all my development in DataOps Develop, following my standard development loop. So I've been developing it here, testing here, and then deploying to the main platform and running it through pipelines when I'm ready. I'm not going to go through the development process in this video because it will make it too long. I may do a follow-up video on that. What I'm going to focus on is the output from this. And by the way, this is the first time I've done any Cortex fine-tuning, and it took me, I would say, start to finish, probably 6 or 7 hours to build not just a version of this that I could show to someone in a demo, i.e. a one-off, but a fully industrialized, operationalized Cortex fine-tuning. So let's go and look at my pipeline. This is going to really be where we launch for the rest of this video, and let me talk you through all the things that are happening. So the first 3 jobs here are pretty standard DataOps jobs. I'm doing my project inheritance. So in a real enterprise application, I would be inheriting reference projects from my department, maybe from my enterprise IT team. That would have all sorts of reusable code that would have, for example, integration into my trouble ticketing system, my data catalog, maybe internal proprietary systems, any, corporate guardrails and things would all come in there. Secrets I'm pulling in from a secrets manager. In this case, I'm using AWS Secrets Manager, but I can use any of the big ones. Setup Snowflake is doing my infrastructure as code. So this is building everything else that I need in here. So this is building my users, my roles, my warehouses, my every other bit of infrastructure I need for this. And then we move into the specific part of fine-tuning. So the first thing I did in the pipeline was to write a job to download the fine-tuning data. Now here I'm downloading it from the from an external URL. Probably more likely, if this was internal, I'd be grabbing this from my existing summarization system. So I'd be running an API call or a set of API calls to grab my fine-tuning data. The next thing, and I'm downloading it and pushing it onto a Snowflake stage. So you can see at the bottom of the job here, the last thing it's doing is using the Snow CLI here to copy it to the stage. The next thing I'm doing is building an actual table against that. So I'm building a model that loads of data from a stage, and it structures in a particular format that I need for fine tuning. And we can just go and look at let's just go and look at that table there. Clean this up a little bit. So if we go and look at my project here, training. So we've got the stages. This is where I loaded the data, and we've got the process data. This is what we're actually going to do our training on. So this is where we can see a set of examples where we're saying, okay, when you summarize the following text, I expect an output like this. And so these are the ones that have been done by hand, either by my people in my company beforehand, or in this case from an external source. And this is what I'm going to use to fine tune the model. So I've loaded the data into some stages. I had to manipulate it because it was in various formats that weren't very useful to me. I've now got it into a simple prompt and completion 2-table column. Next thing in my pipeline is I need to kick off the fine tuning. Now, fine tuning a Cortex model is an asynchronous process. So I kick off my fine tuning and I get an ID back, which is great because this can take quite a long time depending on how much data I've got. So I have one job to kick off the fine tuning model, and I have another job that sits here and monitors that and makes sure that it's running correctly and gets the log output. And then at the end of it, it gives me a list of all of the models that have been created, not just the one. This just allows me to confirm that my model has been created correctly, or my fine-tuned model has been created correctly. Then, so at this point, I've now got a fine-tuned model that I could go ahead and use. But remember, a massive part of building an operationalized system is automated testing and validation. I can't just release this. I might be rerunning this pipeline once a week. If I've still got a bunch of manual summarizations that are being done in my business, and I want to continually or regularly rerun this to refine tune the model based on some work that's been done elsewhere in the company. But I really don't want to deploy this without some sort of validation. I could say, okay, I'll run the pipeline, I'll go and look at the results myself, but that's really kind of missing the point of operationalization and CI/CD. I should get to the point where I can say, well, what tests would a user have looked at, or what tests would a user have run? How do I automate those? And that's what we've tried to encode in the pipeline here. So what I've done is written an analyze function, and what the analyze function does is actually uses a separate model. It uses a much more expensive model. I believe it is the, if I go and look at my configuration here, so I'm using the Llama 3.1 405B, which is a much bigger and much more expensive model to do the validation work. So what I'm doing is essentially asking a much bigger and better model, please go and validate the work that's been done by this much smaller and cheaper fine-tuned model. You may ask the question, well, why would I just not use this expensive model for everything? Well, the clue's in the sentence, it's very expensive. If I'm doing thousands, tens of thousands, hundreds of thousands, of millions of these a day, to use an expensive model for that is very ineffective, inefficient. But using this model to simply validate that I've got a cheaper, probably faster fine-tuned model is sensible and efficient. So I'm asking a big, expensive, but more performant in terms of its summarization capability model, essentially to score all of the summarizations that have been done. So it does 1,500 summarizations, it scores them all, it looks at calculates the aggregate score, and then it does a validate. And it's basically looking, in this case, I think I've set a threshold of 6.5 or something. So it's looking to see, is the average score of all of these models 6.5? If it is, the test will pass. So I've now used fully automated capabilities and further use of an LLM, not just to fine tune a cheaper LLM and a faster LLM, but then to analyze it and bring those together into a single score, which I can then do a pass-fail on using a more advanced model. And once I've done that, then I prepare my new model, which probably means pushing the version to pub, and then I publish it. And at this point, when I publish it, it means I've actually got here version created. So at this point here, my users and all my automated systems and my applications that are using this fine-tuned model are now using the new version. And if you want to go and see the effects of that, we can switch the model from the Mistral 7B to my fine-tuned version of it. So we can now see we've got a summarization here, which is quite a bit shorter and quite a bit more to the point than the ones that we had originally. And they're much more aligned with the ones that we had in training data. So just to summarize what we've seen here, we're taking the capabilities that have been demoed and talked about for fine-tuning a Cortex model, and we've gone through the industrialization process so that we can repeatably, every time someone wants to change a parameter, every time someone wants to tweak something, every time there's some new data available, we can rerun this pipeline. If someone wants to experiment and say, for example, what would happen if I wanted to move from, let's say someone says I want to move from Mistral 7B to Mistral 8, I can simply create a new branch. I can say Mistral 8 testing. Great branch. I can go into the configuration file here. I can change the variable from Mistral 7B to Mistral 8, and I can rerun this pipeline in a completely separate way because it's now in a feature branch, and it will give me a set of scores back saying, hey, this is how much better or worse it was scoring using Mistral 8 as a fine-tuned model, but also how long it would take. So every time there's a new version of a model coming out, and we're all aware that the landscape of LLMs is incredibly dynamic, so the ability to cut a feature branch and simply test a new version of an LLM for performance and cost effectiveness is incredibly valuable, and it will allow me as an organization to stay up to date using the latest capabilities from the various LLM vendors, including from Snowflake, because soon you'll be able to do fine-tuning on the Snowflake Arctic model. So it means I can immediately switch this over and use the Snowflake Arctic model, which will be fantastic. But it gives me the ability to continually try new models, compare them to my existing model. Are they cheaper? Are they faster? Are they better? And if I find that Mistral 8 or some other model I'm trying is better, then all I do is promote this branch. I merge this branch into main. It will go through that pipeline again. It will rebuild everything. It will do the final testing and say, are we sure are we happy it's passed that complete set of tests here? And if so, it'll publish a new model, and everybody in my business will start using a newer model without knowing about it, without needing to know about it. It's just the performance will get better, the capabilities will get better, and the costs will come down. So hopefully that makes it clear what it is first in this series of operationalization, focusing on operationalizing Cortex fine-tuning. Watch this space. This is a series of videos that we're going to be doing. I've started on fine-tuning, but we're going to be doing videos on all these topics and hopefully some more as well over the coming months. So please sign up to follow our feed and our blog feed and see the latest operationalized videos every time they come out. Thanks very much. Bye.